Everyone, welcome back to the Let's Create Breath of the Wild tutorial series. I apologize for how long it's been since the last episode. I feel like I've made a couple of those apologies across this tutorial, but I do have a schedule for finishing up the last few episodes, so hopefully that should be done within the next couple of months. Okay, so let's not waste any more time, so let's get started. So this is the end product. We have all these different metal objects here, and when we activate Magnesis by pressing E, they glow yellow. When we hover over one we want to pick up, they glow purple, and you click to pick them up, and then it creates a beam from your character to the magnetic object, and it'll attempt to follow you. And clicking again will release it, or hitting E will just turn off Magnesis entirely. Alright, so let's get started because I don't want this video to be too long. So first thing we're going to do is let's create a physics object. So I'm going to drag a cube into the world, and I'm going to simulate physics on it. So when I hit play, it will fall to the ground. Probably shouldn't have put it all the way over there, so let's move it over here, and it will fall to the ground. Perfect. And we also want to apply a material to it. So let's go to basic shape material here, and I just use the brushed nickel as my material. And we can open that material, and what we want to do is we want to add a physical material to this material. So let's create that now. So I'm going to create a new folder called Magnesis. And let's open it up, and let's create a new physical material, which is going to be in physics. And just choose physical material, select, and I'm just going to call it PM Magnesis. So let's open that up, and what we need to do is change the surface type to something that isn't default, and this is how we're going to know whether it's something we can pick up or not. So to do that, we need to go to Edit, Project Settings, and I'm just going to search surface type. And let's change the first one to magnetic. So probably did this in the wrong order. Oh, never mind. Okay, it actually showed up. Sometimes you'll have to close it and reopen it to let it show up. So back in our material here, let's just change the physical material to this one we just made. Cool, so now this cube, because it has our brushed nickel material, it considers its surface type as magnetic. So next thing we want to do is go into the character right here. So edit third person character. And what we want to do is we want to add a physics handle. And this just allows us to pick up physical objects. And we're going to start off by just picking up physical objects. So let's go into event graph, and I'm going to bind it to left mouse button. So search for left mouse button, add that, and off of pressed, I'm going to do a line trace by channel. And I'm not going to spend this episode explaining what a line trace does, because it'll take too much time, but I have plenty of other videos explaining them. And if we hit something, we want to check if what we hit is magnetic. So let's break the hit result, and we want to check two things. We want to see if the thing we hit is simulating physics. So we can get the physical material here, and get the surface type, and check if it's equal to magnetic. And if both of these things are true, then we can continue. So if that is true, we want to get the physics handle and grab that component. So let's get the physics handle, and let's do grab component at location. And the component we want to grab is our hit component, and the location that we want to grab it at is at hit component's world location. And we also want to promote the hit component to a variable for later, so let's just do that to hit component. Why not? And make sure we set this after the true. There we go. Now, if we were to test it right now, if we were to click on the cube here, it's technically now connected to our physics handle, but it doesn't follow us yet. So we need to do that by adding a scene to our character, which is just an object that has a point in space, and we want to attach it to the camera so that when we look around, the scene will look around as well. And then off of this, we just want to set this scene's location. So set world location, and we want to set that to the world location of our hit component. Now that our scene is where our cube is going to be, when we click on the cube, we just need to attach the cube to the scene so that when we move the camera around, the scene move around, and the cube will move around with it. So we're going to do that in the tick, so it does it every frame. And first off in the tick, we just want to see if this hit component is valid so that we don't have to continue all that code in case we're not even hitting anything. And we just want to get the physics handle and set the target location to the scene's world location. Okay, let's test that out now. So let's hit play, and if we hit E on our box, if we left click on our box, sorry, it now follows us, which is pretty cool, but we can't drop it, so we are now stuck with the box forever. And I personally wouldn't want that. So what we're going to do is we're going to drop it with left click as well. So when left click is pressed, I can't speak today, when left mouse button is pressed, we want to check the hit component and check if it's valid. Because if we are grabbing something, then we want to drop the thing we're grabbing, but if we're not, we will pick up the thing that we're looking at. So if we want to drop the cube that we grabbed, we can just get the physics handle and we can just say release component. And we also want to reset the scene, so we can just get the scene, set relative location to 0, 0, 0. And we also want to set our hit component to null so that we no longer have a hit component. And then when we ask if it's valid, when trying to pick something back up, it'll go in the not valid and we'll pick it back up. So let's hit play, let's pick it up, let's click again, it falls, and we should be able to repeat that process forever. Okay, so now that we can pick up objects that are simulating physics and are also magnetic, I just want to be able to toggle magnesis on and off. So what we're going to do, I'm going to bind that to the E key. So let me get input E and create a Boolean called magnesis active. So before we toggle magnesis on and off, before I forget, we also want to check if magnesis is active when we try to use it at all. So before we do any of the left mouse button stuff, we want to check if magnesis is active. Otherwise, it'll just be a regular left mouse click. So off of E, let's just get magnesis active, ask an if statement, and do the classic if magnesis active is true, then set it to false, and if it's false, set it to true. Okay, so now if we were to hit play, we can't pick it up because magnesis is not active, so I hit E, and now it is active, and I can pick it up and drop it, and I hit E again, and I can no longer interact with it. Okay, but it's pretty hard to tell that that's happening, so let's create those materials so it becomes a lot more clear. So right click, material, and I'm gonna call this m_magnesis. And what I'm gonna do is I'm just going to create a color by holding down 3, and I'm gonna convert it to parameter called color. By default, I'm just gonna make it the yellow one. And then I'm going to put that into the base color, but I also want it to be kind of glowing, so I'm gonna hold down S and create a scalar parameter called emissive, multiply those together, and put that into the emissive color. And by default, I'll just put this emissive to something like 10. Okay, now we want to create 2 material instances of this. So this one will just be normal, and this one will be hover. Okay, and for the hover one, I'm just going to change the color to more of a reddish, and then I'm also going to increase the emissive because I feel like this one doesn't look as glowy as the yellow one does. Also, we want to make sure in the regular material that we set the physical material of magnetic to this as well. Okay, so the code we want to do for this is when we toggle on magnesis, we want all the magnetic objects to glow yellow and the one we're hovering over to glow pink. So let's go into the third person character, and we want to create another variable called hovered component. Okay, and this one is going to be a primitive component, object reference. So after we check for both is magnesis active, we just want to check all the actors that are magnetic, and we want to turn those yellow. So let's get all actors of class, and the actor class we're looking for is static mesh. So we're just going to get all the static meshes, and we're going to get a for each loop. And from that, we're going to check two things: if it's simulating physics from the static mesh component, and if it's magnetic. So we do that by getting the material. So get material from the static mesh component. Actually, we don't need two of these, so I'll just pull it from here. And then from the material, we want to get the physical material, and then from that, we want to get the surface type. And from that, we want to see if it's equal to magnetic. Kind of a long daisy chain there. And let's just check both of these, so we'll add an and. Okay, so after we've checked all this, we want to see if it's the hovered mesh or not. Because if it's the hovered one, we want to turn it pink. If it's not, we want to turn it yellow. So we'll ask one more if statement. If the static mesh component here is equal to our hovered component, and if it is, we're going to set the material to our hover material, so magnesis hover. If it's false, however, we want to set the material to, not from the mesh though, we want it from the static mesh component, from the for loop, and we want to set it to the yellow magnesis, so magnesis normal. Now, we also want to turn them all back to metal once magnesis is off, which actually is this one. I should have put this here. But we can actually, instead of just copy and pasting this whole thing, we can actually just put it right in here, since almost all of the code will be the same. The only thing that'll be different is instead of directly setting this to magnesis normal, we can get a select and check if magnesis is active. And if it is active, then we can get the magnesis version. So magnesis normal, and if it's not, we can get the brushed nickel. Brushed nickel, there we go. And we can just take all of this and let's collapse it to a function, and we'll call it update material. Cool, so now if we maybe create a few cubes, and maybe a giant sphere, and we gotta make sure to give it the material or it won't work. We can hit play, and then if we hit E, all of these glow. And this one doesn't because I forgot to set it to simulate physics, because it checks for both of those. So now if we hit E, they all turn glowing. If I hit E again, they all turn off. Before we continue, I'll point out that they won't turn pink yet because we never tell the computer what the hovered component is yet, but we're gonna get to that. So we need to go back to the third person character, and we need to get all this line trace code, all of this, and let's collapse it to a function as well, because we're going to use it twice. So collapse to function, and we're just going to call this magnesis line trace. And let's go ahead and open this line trace as well, and we're also going to want the whole checking if it's available as magnesis as an output. And we're just going to call this magnesis available. And I don't know why this happened, but we don't want this false node to go into the return. So back on the tick, we're going to get off the is not valid, and we're going to call the line trace again. So if magnesis is available, and if magnesis is active, then we want to set the hovered mesh, which will be the one that turns pink. So we can get our hovered component and set it to the hit component, and then we want to call update material. So it updates, and then if it's false, we want to turn the pink one back off, because if we don't do this, then ones that turn pink will always stay pink. So if it's false, we just want to get the hovered component and set, can't drag this, set the material, and we want to do the same check as we do in the update material, where we just either set it to the brushed nickel or the regular magnesis. So I'm just going to copy and paste that. And then after that, we also want to set the hovering component to not valid, so we don't have a hovered component. And just to get rid of some bugs, since this will be occasionally be called when the hovered component isn't valid, we can check it. We can add an is valid check to it, because then otherwise the computer will just complain a little bit. Okay, so one quick reason why I realized that this actually isn't working is because we need to go into the magnesis line trace. And we actually have to get rid of this if statement right here. I didn't mean to include that in the function, and check that. And then back in event graph, we need to go to the left mouse button, MAGNESIS line trace, and then add the if statement here. So it's outside of the function. So now if we hit play and we hit E, they should all turn yellow. If we hover over one, it turns pink. We look away, it turns back to yellow. So same with all of these. Okay, so that's looking really good. We can pick them up, stays pink, put them down. There's one thing else you'll notice though, is if we like pick them up and we press E again, well, first off, we still have the one we're holding, and we can't drop it till we turn it back on, and then we can drop it. So we want to drop whatever we're holding whenever we turn MAGNESIS off. So after we turn MAGNESIS off, we want to update the material if we are holding something. So if the hit component is valid, we just want to run the same code that we run here for releasing our object. So I'm just going to drag it like that. So now if we hit play and we pick something up and then we hit E, we drop it and it just all turns off by itself. Okay, so I created this Niagara effect real quick to go between the character and the object. This isn't a tutorial for that beam, but I will show you the settings real quick for the people who want to just copy it down. What I did is I created go into FX, create a new Niagara emitter, new emitter from template, and then I started with a static beam and I just created a new one, and I'll just show you all the things I changed. Okay, so in spawn burst instantaneous, I just have 100 for the spawn count. In beam emitter setup, for beam start, I just have simulation position, which I think is the default, but for beam end, I have a user end location. And to get this, we're gonna go to user expose right here and create a new variable of type vector and just call it end location, and then just drag this over and put it right here. And this will allow us to update that in blueprints and make sure absolute beam end is checked. For the beam start tangent, just click on this arrow and I just typed in make vector, which split the vector into an X, Y, and Z. For X, I left it 0, but for Y and Z, I just made it a sine by searching sine, clicking there. For beam end tangent, I did the same thing, make vector, and then for Y and Z, I did cosine. That allows the beam to kind of spin around while it's being grabbed, kind of like this. For beam width, if this wasn't by the default, I just changed it to float from curve, and this is what I made the float look like. For scale color, for scale RGB, I just did a multiply vector, and then for A, I did linear color, and then from color, I did color from curve, and then the curve, I just added these 4 points. I did red, yellow, green, and blue. And then for B, I just did a vector from float, so just search float, and then I put the value as 50. This will work like the emissive, which will make it glow. For the scale alpha, I also did float from curve, and then I just made this scale going from time 0 value 1 to time 1 value 0. And for curve index here, I did ribbon link order. I added a curl noise force, and these are the values. I did a scale sprite size, which is vector 2D from float, value is float from curve, and then this is the graph again, 0, 1, 1, 0. And then I actually ended up disabling the ribbon renderer and adding a sprite renderer, which uses the default sprite material. If you look that up and it doesn't show up, go to view options and make sure to check show developers content. I believe those are all the changes. So after I made that, you just right click on it and do create Niagara system. That's what this is. We open this up, and this is kind of like making a instance to a material, and the only changes I made in this instance is in the sine and cosines. I thought the waving was way too high, so I changed the scale to 0.1 for all 4 of them, and I believe that's the only change I made. You can ignore this node right here. So that gives us this effect right here, and in the third person character, we just need to spawn it now. So off of the left mouse button, after we grab the object, we just want to spawn the particle system. So we'll do spawn Niagara spawn system attached. The system is going to be our beam. The component I'm attaching it to is the capsule component, and then I'm going to promote it to a variable. I'm just going to call this beam. And then we also want to adjust the end location, which is that variable I created in user exposed. I called it nlock. You need to make sure you know the name because it needs to be spelled the exact same. So I'm just going to do vector3 and set Niagara variable vector3. Make sure you type in the name exactly the same. And the in value is the world location from the hit component. Okay, cool. So now when we pick up an object, we should get the beam. There it is. But as you can see, as soon as I move the object, the beam does not move with it. So we need to add that to the tick. So let's go down to the tick. And we just actually just want to copy and this set Niagara variable, paste it on the tick after physics handle set target location. The target is going to be our hit component get world location because we want it to update to our object's location. And then the target is our beam variable. Okay, now when we hit play, we pick something up and the beam follows it. That looks great. Drop it again, but the beam is still there. So we have to make the beam disappear when we drop it. And luckily that is very easy. We can just come up here and then after left mouse button, once we drop the item, we just take the beam and we destroy component. All right, one more test. Oops. There we go, and the beam's right there. And we drop it again and the beam goes away. Same thing should happen when we just pick something up and then hit E and everything just turns off. Okay, that looks good. Okay, so that's really the basics to all of Magnesis. There's a few variables I'm gonna tweak now. Everything after this point is optional, but if you want to make the look and feel a little better, this is how. So for the camera boom here, I just took the socket offset and put 50 on the Y and Z so that it would be a little over the shoulder shot. If we take the physics handle, I adjusted some of these values, the angular damping to 250, the angular stiffness to 150, and the interpolation speed to 10. I think the interpolation speed adds a lot to this, a lot to the feel of regular magnesis because it takes a second to catch up rather than just following us so perfectly. What I also did to simulate things feeling heavier is I added a variable called sensitivity and make it a float. And default value should be 1 because we're going to multiply it to the mouse input axis value. This is just how we handle sensitivity, and we're going to do it for both. Cool, and then we can just adjust the sensitivity value and that will simulate heaviness. So the way I decided this is I decided the heavier an object is, the slower the mouse moves when you try to move it. So I do that by getting the mass, which is automatically calculated if you don't have this checked. So after we pick the object up, after all this, we just want to set the variable to the hit component. We can get the mass. I'm going to divide the mass by 2500. That'll give us a more reasonable number for sensitivity. I'm also going to clamp it just in case so it can't get too crazy in either direction. So max will be 1, minimum will be 0.1, and then I'm just going to get the sensitivity variable and divide all of that. And then when we release the component, we want to set the sensitivity back to 1. So set sensitivity to 1. Oh, I see. I was not supposed to put the clamp here. The clamp is supposed to go after the second divide because we want the end result value to be in between 0.1 and 1. So let's try this one more time. So we grab this, and yeah, it's a tiny bit slower. And we grab this, and it's more slower than the cubes. All right, so that is Magnesis for you. I hope this video was helpful. I had a good amount of fun making it. And make sure to hit like and subscribe. It really helps out with the channel. And if you're interested, I'm making a video game of my own right now, and I have a couple devlogs on the channel if you want to check that out. All right, I'll see you next time.